Last week we looked at technology in the ancient world and examined some of the innovations that helped early civilizations to develop. This week we're going to be moving forward into the classical world, particularly ancient Greece and Rome. Our reading this week, Classical Civilizations, gives us a good opportunity to think about what happens when societies take technologies that already exist and begin improving, adapting, and applying them in new ways. That is an important distinction because many of the technologies we associate with Greece and Rome were not completely new inventions. Instead, the Greeks and Romans often built upon knowledge that had developed over centuries. As you work through the reading in this week's section of the course, I want you to think about one big question. Does technology progress require the innovation of something completely new, or can progress also come from improving and applying existing technology? The reading this week begins by reminding us that by the time the Greek civilization emerged, humans had already developed many of the technologies necessary for civilization. People had already begun practicing agriculture. They had domesticated animals. They worked with metals. They spun and wove textiles. They produced pottery. They constructed buildings from wood, brick, and stone, and they used wheeled transportation. So the Greeks and Romans were not starting from scratch. In fact, the reading kind of points out that agriculture remained the foundation of the economy and that most production still occurred within the home. Most importantly, the primary sources of power remained human and animal muscle. That last point is particularly important. Today, when we think about technological change, we often think about how machines are replacing human labor. In the classical world, however, most work was still depending upon people and animals. The challenge was often figuring out how to make that labor more efficient. The reading also introduces us to three important Greek inventors: Ctesibios, Archimedes, and Heron of Alexandria. Ctesibios experimented extensively with air and water pressure. His work helped to contribute to the development of hydraulics, and he developed devices including a force pump and improved a water clock. The water clock, which I have something similar pictured here, is a good example of technological innovation responding to a practical problem. Sundials could tell time when the sun was visible, but what happened at night or when the weather was cloudy? A water clock offered another solution. Archimedes combined mathematics with practical mechanical problems. The reading credits him with inventing the lever gears and devices for moving water. The relationship between math and technology is something worth noting. Increasingly, knowledge about mathematics and the physical world could be applied to practical problems. And then lastly, we have Heron of Alexandria. Heron developed and described surveying equipment, presses, mechanical devices, and even machines that were operated through air, water, and steam. Some of these were extremely clever, but here's the catch. Many were essentially toys or demonstrations rather than machines designed to transform everyday work. And that leads the reading into one of the most interesting debates that we'll sort of look at this week. Why didn't ancient technology go further? If people understood concepts involving steam, gears, pressure, and mechanical movement, why didn't the ancient world experience something resembling an industrial revolution? One explanation that's important for what we're going to look about sort of over the course of the next few weeks concerns slavery. Several historians have argued that because Greek and Roman societies had access to enslaved labor, there was less incentive to develop machines that replaced human muscle. This is the type of argument and the type of thing that is going to continue on throughout many different points in world history. Many worried that if they created more expensive and more technical types of inventions, then enslaved labor could potentially break these inventions as a way of resistance, of sort of taking their time back against their enslavement. So, because of that, what's very important for us to understand is that slavery is a consideration. According to this argument, if human labor was readily available, then why invest in labor-saving machinery? The reading this week does sort of challenge that interpretation. In the reading, he points out that the Greeks and Romans actually did create devices intended to reduce labor. The screw press, pumps, gears, and other machines could all make work more efficient. So rather than simply saying something like, quote, the Romans had slaves, therefore they did not need machines, the reading asks us to consider a more complicated relationship between labor and technology. This is something I want us to keep in mind again over the course as we look at this. Technology does not develop separately from society. Economic systems, labor systems, political institutions, and cultural attitudes can all influence which technologies people develop and how widely those technologies are used. One of the best examples in the reading is the water wheel. Grinding grain and lifting water were incredibly labor-intensive jobs. Human or animals normally provided the energy needed to perform this work. Eventually, people realized that flowing water itself could provide that power. It sounds simple to us, but conceptually, it represented an important change. Instead of asking, how can we make human labor more efficient, people began asking, can something other than humans or animals provide the power? Water mills eventually used flowing water to grind grain and to perform other types of work. The reading also calls an important turning point because it does help to introduce the possibility of substituting another energy source for muscle power. However, there are limitations. A water wheel needs access to sustainable flowing water. Transportation is also difficult, meaning that even a useful technology can be impractical if it's located too far away from the people who need it. So you have to think about the consideration of where are these flowing water sources, things like rivers. Are they close to the centers of production where they need to be? It's also a great reminder that inventing technology does not automatically mean that society will immediately adopt it or immediately adopt it in a way that is going to shift things like labor systems. Another major theme in this week's reading is the relationship between warfare and technological development. Greek and Roman society spent enormous amounts of time fighting wars. As a result, military needs encouraged technological innovation. The Greeks developed siege technologies including catapults, battering rams, and siege towers. The Romans adopted and improved many of these technologies. But one of Rome's greatest military technologies does not look like a weapon at all. Instead, it would be the road. Rome needed to move armies quickly throughout an enormous empire. The Romans responded by constructing vast road networks. They cut through hills, crossed rivers with bridges, drained roadways, and paved surfaces with stone. The reading estimates that Romans constructed around 44,000 miles of roads. These roads helped Rome to move soldiers, but their impact also extended far beyond warfare. Merchants used them. Government officials used them. Traveling information could also be passed along on these roadways. So technology created partly to maintain a military and to maintain political control in a very vast empire also helped over time to encourage trade, communication, and cultural exchange that has long-lasting impacts on the world even today. Roman technology was also closely connected with the growth of cities. Large populations require enormous amounts of infrastructure. People need clean water. Waste has to go somewhere, and goods have to enter and leave the city. Buildings have to accommodate large numbers of people, and for the Romans, they developed an extensive aqueduct and sewer system to help meet these needs. By around the 3rd century, 11 aqueducts carried water into Rome. The Romans also constructed public baths, which became important parts of urban life and places where people could talk about larger ideas. Think about what this tells us about technology. An aqueduct is not simply an impressive piece of engineering. It also represents an attempt to solve a problem. How do you provide water to a massive urban population? The growth of Roman cities created new demands, and engineering helped to make way for those cities. The Romans also became famous for their constructions. 2 developments discussed in the reading were particularly important: hydraulic cement and the arch. The Romans discovered that mixing certain volcanic material with limestone created a cement that could resist water. They also made an extensive use of the arch. The Romans did not invent the arch, but they developed it and applied it to an enormous scale. This allowed them to construct bridges, aqueducts, baths, arenas, and other large structures. Again, we see the same pattern. Roman technological advancement often came not from inventing something completely new, but from taking existing ideas and applying them more effectively and on a much larger scale. And this brings us to something I think is important in the reading. The reading argues that the Romans deserve their reputation as great engineers partly because of their ability to organize. Engineering requires more than inventing a machine. You need materials, workers, money, transportation, and planning. And you need a government or an organization capable of organizing and coordinating all of those resources. The Romans inherited technology from early civilizations, adopted Greek innovations, and applied many of them across an enormous empire. So as you go through the reading for this week, think about technology more as a collection of inventions. Think about the society surrounding those inventions. What problem was a technology dissolved to solve? Who benefited from it? What resources were required to make it work? And why did some technologies spread while others did not? These questions will continue to be important as we move through the course and begin looking at later periods of technological change.